Okay, so this video is about how do you draw a Bohr-Rutherford diagram. Now, mainly we're going to talk about the first 20 elements, okay? So in this case here, now just to keep in mind, when we're talking about Bohr-Rutherford diagram, you do have a limitation of how many electrons each shell can carry, okay? So in this case, for the first 20 element, the first shell, you can take 2 electrons. The second shell, you can take 8 electrons. The third shell, you can also take 8 electrons. And the fourth shell, you can take up to 2. Now, technically, the fourth shell can take a heck of a lot more, but keep in mind, we're talking about the first 20 elements simply because once you get beyond the first 20 elements, then you have to talk about subshells and different things. So we're going to keep it simple, okay? We're going to keep it simple for now. You don't need to learn that until you're in grade 12 chem anyways. Now, first of all, you do need to know how to find the number of protons, neutrons, and electrons. So I'm going to use one of these examples from before. So let's just use the aluminum one, okay? Now, for the aluminum, based on the periodic table, we found out that you have 13 protons, 14 neutrons, and 13 electrons. So what we do, and you always draw with a pencil, okay? The reason why is because pencil, if you made a mistake, you can easily erase it. So for aluminum, so I'm here. The first one, you're going to draw a circle that shows as the nucleus. So you have 13 proton, you have 14 neutron, and you have a total of 13 electrons to put away. So the first shell, you can put 2 electrons. So let's do that, 1 and 2. The second shell, you can put away 8 electrons here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? Or to be a much better diagram, what we should have done is 1, 2, 3, 4, 5, 6, 7, 8. Simply because electrons are negative, they like to be spread apart as much as possible. That's why it would be 1, 2, 3, 4. And then the fifth one would be like a pair, 5, 6, 7, 8. Okay. So if we look here, we have 2 plus 8. That's 10 electrons already. We just need about 3 more. So on the third shell here, we have 3 more electrons. So 1, 2, 3. So that will be a Bohr-Rutherford diagram for aluminum. Okay, so that's pretty fine and simple. Let's do another one. Okay, so let's just say we want to go figure out the fluorine. Okay, fluorine. And as you can see from here, fluorine, you have the atomic number is 9. The mass number is 19. Atomic mass number is 19. So first off, the number of protons would be same as atomic number 9. Number of electrons, that would also be number 9. And number of neutrons, that will be the big number minus a small number. Okay, 19 minus 9, that will give you a 10 neutrons. All right. Now we're going to draw the Bohr-Rutherford diagram. So first of all, this is the nucleus. So you have 9 proton here and 10 neutron here. You have 9 electrons to put away. So the first shell here, you have 1 and 2. So I put away 2. I have 7 more electrons left. The second shell, I have 7 more electrons to put away. Thankfully, we can put them all in here because you can put 8 here. So 1, 2, 3, 4, 5, 6, 7. Okay? So in this case, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 electrons here. So that will be the Bohr-Rutherford diagram for fluorine. Okay, so make sure you do some practice, and you will notice after you draw the Bohr-Rutherford diagram of a 20 element, you will notice some distinct pattern. which is rather interesting. Okay, I hope you understand this. Let me know if you have any questions. Good luck.